Hello everyone, welcome to Shiwam's classes. In today's lecture, we are going to discuss problem number 11 to 13 of chapter 6. We have already discussed problem 1 to 10 in previous videos. Please go ahead and watch these videos which are given in my playlist. So let's start with this problem first, which is this problem number 11. So it's given that an aeroplane is leaving an airport and flying due north at a speed of 1000 km per hour. At the same time, another airplane is leaving the same airport and flying due west at a speed of 1200 km per hour. How far apart will be the two planes after 1.5 hours? So if you look at the problem, what it is saying that there is a plane flying in one direction, another plane is flying in another direction, and so how far apart they will be at one particular point of time, right? So let's draw the figure and then we can understand this problem better. So say this is your system. So when you look at our directional system, this is treated as north, this is treated as south, this is treated as west, and this is treated as east. So one of the planes is flying in this direction north, another plane is flying in this direction west. This plane is moving at 1000 km per hour and another plane is moving at 1200 km per hour. So first of all, we need to know after 1.5 hours how far this plane would have moved and how far this plane would have gone. So assuming that this is the point from which they are starting, so let's understand in 1.5 hours how far the planes will be. So we know that the distance covered would be a speed into time, right? So now my speed is 1000 km per hour. And my time is 1.5 hours, so 1.5. So this distance is 1500 km. Similarly, for the other plane, the distance covered would be 1200 km per hour into 1.5, which is nothing but 1800 km. So now what we have over here is one plane has moved for say 1500 km from here to here, and another plane has moved 1800 km from here to here. So now we have to find out the distance this one. Again, as you can see, this is nothing but a right angle triangle, right angle here, and this distance is 1000, this is 1500, so we can find out this distance, right? Calling it O, calling it A, calling it A. We know in right angle triangle, in triangle OAB, angle O is 90 degree. So this implies AB square equals to BO square plus OA square from Pythagoras Theorem. Now BO square is nothing but 1500 km square. OA square is nothing but 1800 km square. So now 15, 15, 2, 2, 5, and then there will be 4 zeros. And then similarly 324 and then 4 zeros. Now when you sum it up, it will be 4, 5, 9, 2, 2, 4, 3, 2, 5, 5, 4, 9, and then 4 zeros. So AB would be what? AB would be square root of 549 into 10 to the power 4 we can write. Now look at 549. Can we factorize 549? Let's see. So since last digit is 9, so it will be divisible by 3. So let's write 3. So 1, 8, 3. Then again the last digit is 3, so it will be divisible by 3. 3, 6, 18 and 1. Now this number cannot be divided further. So we can write 3 square into 10 to the power 4 into 61. We take out these two integers outside of square root. So this becomes 3 into 10 square. So as you know, right, this is a square. So when we take out of this square root, it will become 3, and similarly to the power 4 will become to the power 2, and then 61 remains here, and this will become 300, and then this is 61 kilometer, right? So this is going to be your answer. Now let's move to the next problem. What's my next problem? My next problem is this one. It's given that there are two poles of heights 6 meter and 11 meter standing apart on a plain ground. If the distance between the feet of the poles is 12 meter, find the distance between their tops. So what is given is that there is a plain ground, something like this, there is a plain ground. So there is a pole standing which is say 11 meter of height, and then there is another plane which is like 6 meter of height. So we need to find out the distance between the tops of these two poles. We have been given the distance between the feet of these two poles, which is given as 12 meter. This is given as 6 meter. This entire thing is given as 11 meter. Now let's assume we drop a perpendicular from here to here. So since this distance is 6 meter, this will also become 6 meter. Since this entire distance is 11 meter, this will become 5 meter. Since this is 12 meter, this will become 12 meter. Right? Right angle, right? So call it A, B, C, D and E. Now in triangle DEC, using Pythagoras Theorem, can we write BC square equals to DE square plus EC square? Why? Because the angle is 90 degree. Now DC square is what we need to calculate. DE square is given as 12 meter square. This is given as 5 meter square. This will become 144. 12 square is 144. 5 square is 25. This will become 169. This becomes DC becomes square root of 169. This becomes 30, and that is the answer. Right? Now let's go to the next problem. What's my next problem? Let's read this problem. Given that there are D and E2 points on the sides of C and CB respectively of triangle ABC, which is right angle at C, prove that A square equals to BD plus BD square equals to AB square plus D square. So let's first make the figure. Given that there is a right angle triangle, so let's make a right angle triangle first. There is a right angle triangle. Alright. Right angle at C, then this is A, this is B, and this is the right angle at C. Given that there are D and E points on side CA, so there is a point D somewhere here, there is a point E somewhere here is what is given, and now this is what is we need to prove. This is what we need to prove. AE square. We do not have AE as a side, right? So let's join AE. BD square, we do not have BD also, let's join BD. Then equals to AB square, AB is already there, and DE is also not there, so let's join DE as well. Alright, so now you can see that there is a right angle triangle. This is also a right angle triangle. If you look at CED is a right angle triangle, CBD is a right angle triangle, CBA is a right angle triangle, CEA is a right angle triangle. So there are a lot of right angle triangles, and we can very well use Pythagoras Theorem in all of them. So first of all, what is given? AE square. So let's write AE square and BD square, whatever is given on the left hand side. Let's write LHS. So LHS is given as AE square plus BD square. Now look at AE square. What is AE square when you are looking at in this triangle in ACE? So AE square is the hypotenuse, so this will be equal to sum of perpendicular and the base. So what is perpendicular? Perpendicular is CE. So we will write AE square is nothing but CE square plus AC square. AC is the base. Similarly, what is BD? BD square. When you look at BD, this is again part of this triangle, right angle triangle BCD. So BD is again hypotenuse. When BD is hypotenuse, then what will be BD square? BD square is nothing but height square plus base square. So BC square plus CD square. BC square plus CD square. Now my CE square is given, right? See, this is what we have done. Now on the right hand side, you can see that there is AB square, right? When you look at this bigger triangle, AB square is nothing but BC square plus CA square. So we can combine CA square and BC square together and CE square and CD square together. So let's put them together. AC square plus BC square together, and then rest of them together, CA square plus CD square. When you look at AC square plus BC square, AC square plus BC square is nothing but AB square in the bigger triangle, ABC. So AB square. CE square plus CD square, CE square plus CD square is nothing but D square in this triangle, because D is the hypotenuse in CED triangle. So this is basically this is your ED square. You can write it again as AB square plus D square. So maybe you want to write from triangle ABC and triangle CDE. Here as well you could write in detail as to which triangle you have looked at and then how did you arrive at it. You can write here using triangle AEC and triangle DBC. So here basically you can write this, here you can write, and in all of them using Pythagoras theorem is what we are using Pythagoras theorem. So you can see that all these problems are being solved using Pythagoras theorem. All you have to look at is that how to make this triangle a right angle triangle. Once you have done it, you look at the which is the hypotenuse, which is base, which is height, and then work with that. So this is how you will solve this problem. So let's look at another problem if we can. We do have time. So let's look at this problem as well. What's this problem saying? So this problem is saying that the perpendicular from A on side BC of a triangle ABC intersects BC at D such that DB equals to 3CD. So DB, this part is equal to 3CD it seems, right? So look at BC. Say any time when this kind of entity is given, right, you try to resolve it in the bigger side generally. Why? Because when you look at the entity which you need to prove, what we have over here is AB square, which is this side, AC square is this side, and BC square is this, right? You do not have CD or BD, right? So we try to reduce it into BC itself, right? So we can write BC is what? BC is CD plus DB. CD is alright, but DB is 3CD, so we'll write 3CD. This implies BC equals to 4CD. This implies CD equals to BC by 4. This implies DB equals to 3CD, right? Equals to 3 into what is CD? BC by 4, right? So this is what we have, 3 BC by 4. Now let's look at LHS of it. What is LHS? Which is AB square, but rather 2AB square. So let's write LHS LHS equals to 2AB square. So 2 times AB square is what? AB square is nothing but AD square plus DB square. AD square plus DB square. Using again Pythagoras theorem. In triangle ADB. Now 2AD square. Look at AD. AD, what would be AD in terms of AC and CD? So can we write AC square minus CD square? AD square equals to AC square minus CD square plus BD square. Since AC square equals to AD square plus CD square. from Pythagoras theorem again, from Pythagoras theorem. Now you can write 2ac square is alright. Now write CD, what we have CD as BC, BC by 4 whole square, plus what is my BD? BD is nothing but 3BC by 4 whole square. Is that it? Now my 2 AC square minus, now let's take BC square by 16 plus 9BC square by 16. Further try to solve this part again. We have 2 AC square plus, take 16 as LCM, then this will become minus 1, this will become 9BC square, alright, which is nothing but 2AC square plus 8 by 16 BC square, 8 2 is 16, so 1 by 2 BC square, which will become 2AC square plus BC square, which is nothing but RHS, right, which is what we need to prove. Alright, so in this lecture we have discussed from problem 11 to 14. In the next lecture we will try to conclude this exercise by finishing off 15, 16 and 17.